Alright, so F it. What we're going to do is we're going to implement that frickin' monitor, because that should be really fast to do. That should be really fast to do. It should take us not that long. And then it will be running on here, and then we can poke at memory all day long, including the floppy controller, and not have to frickin' burn ROMs over and over and over again. How about that? That would make our lives way frickin' easier. And then we can test code out on there before we actually, you know, write it out and put it on a ROM. So let's do that, why don't we? That is not right. This is right. Let's go over here. So let's see if I still have it up, actually. Yeah, here we go. This is the source. This is the whole frickin' thing. Yeah, CMON. This is it. So this is some person. Apologies. It's apparently Big Ed's repo, but I'm pretty sure this is... Oh. Yeah, so written by Bruce Clark and placed in the public domain, but I want to make it clear. Whoever Bruce Clark is, I'm not familiar. He might be a known person in a scene, but he wrote this. I want to be very clear. And Big Ed Spittles, is the person who took this code and ported it to CA65, which is awesome. I wasn't even looking for that, but that is the assembler we're using. So, yeah, that is pretty dope. Pretty much the only configuration I've seen in here, it looks pretty straightforward, is there's this single-step thing which enables a single-stepping option. I'm not entirely sure how that works, but pretty cool if we can include it, but I won't include it for now. And then I'll have to look what width and height are, because it's not really clear down here. I mean, I'm guessing that's like maybe the window size and characters that it prints stuff in? I don't know. We'll figure it out. If it looks weird, then we'll do that. And then these are pretty much, you write a routine for doing your input and doing your output. This part I find slightly confusing the way they've written it, but I don't know. I think I just need to redefine this to wherever the actual label for my input method is. I'm guessing, like, for these macros, like, I just replace all of this with JSR input and it would be fine. And then redefine these. Don't even use these, just, you know, define labels somewhere for our input and output subroutines, which we have already written. And then there's a whole bunch of other single-step stuff. Looks like we can move stuff around in the zero page, which we will need to, because we have zero-page registers that we are using. And then I think, yeah, it looks like init is... Oh, that just goes straight to this mon label. So I believe this is the entry point, because they don't, I don't think they, like, define, whatchamacallit, the actual vectors in here. I think we would need to do that ourselves. So my rough thought is just grab all this code, stick it in our editor, jam in the bits of our code that do the input and output, and, like, we're done. And we should be good. So let's just do that, eh? Let me download this shit. Save, there we go. I know how to run a browser. And I am just going to save this to... Oh, no, it was documents. I know where my stuff is, too. Look, it's been a long day. And trust me, this is just about to be the beginning of a long night. Yeah, cmon.a65, bam, saved. .a65.text, sure. That's fine. You know what? No, that's not fine. That's not fine. You deserve to be named the way that you are actually named. And I see I have a bunch of chat going on, so I will get over to that, but I wanna get a little bit spun up first before I look over there, so that I don't get too derailed too quickly. Oh god, stupid freaking Windows. Can't believe this is still a thing. And I can't believe I still have this set to the default. Don't hide extensions for known file types. It is the stupidest thing you ever did. Nope, accidentally deleted the file. Super, super cool. This is off to a good start. Let's just not put text on it from jump. There we go. And now we can open that over here. Where are you? Where are you, Simon? Does this not immediately refresh? Oh, there's a refresh button. I don't think I've ever once needed to use that. And it's still not... Oh, because it's in the source folder. That would be why. Alright, well, let's just open the file then. If you're gonna be like that. Simon.a65. Lovely. I'm curious if there's... Yep, there's a C65 macro assembler package. Perfect. Love it. Great community Visual Studio Code. Look at how pretty that is now. Okay. So, we've got this. Not sure if it defines things as being in, like, a particular region. What's it called? You know, like BSS and text and whatnot. What the heck are those called? It has totally escaped me. Anyway, doesn't look like it's defining any of those. So I'm not sure if I will have to do that, but I'm going to... Let's do two things. One, let's take basic.sm, save off a copy of it, and call it... I don't know, I'm just going to call it original basic.sm, because I lack a creative bone in my body. And now let's open back up basic.asm, and let's open up, even though it's like right over there, isn't it? Original basic.asm. And I'm just going to blow up this entire file. I think I will leave segment code main for starters. Let's see. We can delete a lot of this stuff, but some stuff it just makes sense to leave, such as this stuff I'm not going to use anymore. Entry is still going to be our entry point, but we'll have this call in it from the monitor code. All of this setup stuff, bloody, 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 blah. This all matters. Setting up, setting up, setting up, setting up, setting up screens, setting up enabling rendering, setting up the MMC3, setting up the MMC3 some more, initializing the keyboard, resetting the floppy, sure, we'll keep that as well. And then basically I think everything from here we can get rid of and replace it with basically just straight up the monitor code. Just making sure I don't screw anything up too bad. Okay, yeah, everything up to us looping the halt loop thing. Note to self. Insert monitor here. Lovely. And then, like, I mean, I don't even really need this, but we're gonna need something for that anyway, so I will leave it. And the rest is just, let's see, init keyboard, get key, print char, print string, which actually I won't need this, at least for this code. Cool, cool, cool. That's all our scrolling code for printing, and then we have our lookup tables, which we will still need. And our blank at the end, and our vectors, and that is that, ladies and gentlemen. So, I can now paste in some monitor code, which it's really small and very simple, so this should not be too bad at all. So right here, insert monitor here. I'm just going to. I realize I could probably like assemble them separately and you know, link the CMON code, but I'm not going to because I don't feel like it. Also, it's not CMON, it's CMON, which is pretty good, honestly. I like that. Okay, let me get this copied over and fix up the first obvious things like the 0-page values. What am I doing? This is Vim. I can just select it all. There we go. And now we have the CMON code here. We'll figure out what width and height are someday. And yeah, 0-page stuff. So where does our 0-page stuff end up? It ends up all the way up here. It's in need of refactoring, as Wereworm said the other day. That is to put it mildly. Okay, so the last thing we're using is 0C, which is actually, we're not even really using that because that's for the motor toggling. Yeah, we can just get rid of that. So 0C and 0D are what we have available for the monitor locations. So let us change those. So, oh, 0C and 0E, because that address is a 16-bit address, as it turns out. And that is almost entirely it, except I need to redefine these macros. Oh, yeah, so I can just change these to JSR get chair. Get chair? I have a chair. I'm sitting in it. JSR get char and JSR put char. The one thing is, I was reading the documentation, you need to make sure, in fact, let me go look in the documentation again. You gotta make sure they leave some variables untouched, or some registers untouched. So they gotta preserve Y, and I know they don't already because they screw with our existing code and I've had to deal with it. So they need to preserve Y and the D flag, which I'm pretty sure there's a 6502 instruction to like transfer the status register into the accumulator, right? I think so. So we'll just do that, I think. Maybe. And then, let's see. Output should also preserve the accumulator. And then they also have this out carriage return routine that you can modify, but I think that already works the way that ours is supposed to. So this is actually kind of a fun dry run for porting BASIC, because obviously this is going to be way easier than that, but this is kind of how it should work. Is mostly drop in those routines and we're good to go. So, yeah, I will do that in just a second here, but let me check a little bit of chat, because Wereworm is asking about the plumbing. Wereworm says evening. Evening. And how is the plumbing? Fixed. It was actually, it was just the cartridge that was busted. I forget that cartridges are a thing in plumbing valves for fixtures. I should know this. I have had to replace them before, but it's been a while and I totally forgot. And I thought I was screwed and would have to open a hole in the wall, but I did not, because that shower's never had that kind of plumbing work done on it before, so the wall has never been opened behind that shower. So I was kind of not going to be happy about that. But of course, it's just the cartridge. The cartridge was broken. Lowe's was open at 6 in the morning, and they had those cartridges in stock, so it was amazing. I woke up, ran to Lowe's, picked it up, replaced it this morning, good to go. We're all set, which is fantastic because we have family staying over right now, so very nice. Hello, Daniel Rodriguez, good to see you. Kyle Steinkamp says, Konnichiwa. It's a side story. So we just went to like a baby clothes and toys and stuff consignment super sale thing. It was actually really cool. You know, if you have a baby. It was pretty neat. Like a flea market kind of deal almost. And we're just walking along, and we walk right past a Japanese couple talking Japanese, and I'm so awkward in that situation. Not because I act, well, because I do act awkwardly, but I so want to let these people know that, you know, this random white guy speaks pretty okay Japanese out of the blue, that they're not expecting in the middle of Midwest bumfuck, which is, of course, in and of itself very, very awkward and stupid. So, anyway, that was fun. That's all Konnichiwa reminded me of. Is I always want to do that, and it's always what a faux pas that is. just you know, speaking some Japanese and hoping they will hear. I'm a silly man. Anyway, Tip says hello. Trey Dempsey is here. He says hola. Good to see you, Trey. I feel like I had something I was going to say to you, but I can't remember. Oh, I keep asking every time. I should just ask you this in private instead of on the stream. But HashMap. Do you work for HashMap? Because that would be funny. If you say yes, I'll tell you why that's funny. You used to. Okay, so you are that because you're on a podcast. I think you would know that. And I was creeping my my like 3 top people just to see like how they are. I guess it's not as cool anymore, but I too work for an NTT Data subsidiary. So there you go. I just thought that was pretty good. Taco Man said, finally got a chance to see the stream. Was at the hospital for 4 days. What the living shit, Taco Man? What happened? What happened? Yeah, I work for a little, it's not Michigan local, it's actually technically located in the Bay Area, but one of their big offices is here in Michigan, called Nexient, and we were recently bought. But now it doesn't matter, because you don't work for HashMap, so. But I guess NTT has, yeah, I'll tell you about it on Discord. NTT has been snapping up, little independent contract shops. So that's fine. More stability for me. Okay, anyway, back to things now. Oh, Taco Man says heart fucking up again. That sucks, dude. Hearts are... I mean, they I don't know where you're from, but they kill a shit ton of Americans, those hearts. Yeah. Alright. So, was it Trey that was saying just include a monitor already? Because I don't know if you caught the beginning, but I'm just including the monitor, so whoever it was that was saying that, you win. Okay, so there are 2 things we need to do. 1, delete these. I think they're just giving you a bunch of options for how you can define this stuff, because I think what I would just do here is JSR. Nope. Wow. Correct word. Putcher. What did is it called Putcher? Did I accidentally delete it? That would be very funny. Where are you? Where are you? Where are you? Putchar. Perchar. You'd think I would remember after all this time, because it's the weirdly poorly written one. Perchur. Okay, so JSR Perchur, and that's pretty much it, because supposedly they access everything through these macros, is how I understand it. Oh, wait, interesting. Hold up. Because I don't get... It's just so weird the way this is written. So they put two literal bytes that are 42.0 and 42.1, which I assume hex 42 is... Like, I'm getting too off in the weeds. This is not important. I'm sure it will work regardless, but... what am I even looking for? Oh, right, what the 6502 instruction set... Because I bet 42 is JSR. So why... But then it's only 1 byte. And JSR requires a full address. Oh, unless 42 is JSR a 0-page address? But that's... I don't know. I don't get what's... Maybe there's better documentation on the page and I should just read. Taco Man says, I'm in Florida, so it took way too long just for a CT scan. Ordered first day I got here, and it took 3 days just to get it. Woof. I have nothing more to say than woof. That just blows. Anyway, yes, for my own curiosity, JSR. Nope, so that's 20. And there is only one JSR. So, what the frick is this 42 business? Let's see. 42 is not an instruction. I don't know what that's about. My only thing that I was wondering is that it's then doing store A to this address? Is it expecting... Like, is that important? Do I need to uncomment that? Is it expecting in the subsequent code... Well, no, that's insane. That would be like, on almost every 6502 system ever, that would be a ROM area. So, here's what I'm going to do. I'm just going to go with my gut, and I am going to just use the JSR output, and, or, again, in this case, it's going to be JSR purchur, and JSR get... No. Okay, what's that called? God damn it. Oh, is it get key? It's probably get key, isn't it? Wrote this code and don't even know what's in it. Uh-huh. Get key. And then I don't know what those are about, but we're ignoring the hell out of them right now. And then let me check really quick to see if things actually use these macros, because if they use input and output directly, then, well, that'll tell me some things. Yeah, no. So it just uses getC. In fact, let's look for all instances of output. And, yeah. There are none. Cool. So it does everything through the macros, which... That's a weird way to do it when your macro doesn't really do anything. But fine, I will play your game. Trade MC says, don't you have to modify your code to preserve your registers? Damn straight I do. I'm almost wondering... Because, I mean, it uses this as a macro, so what if I just do the register preservation stuff inside of the macro? Like, I don't see why that would be an issue. Right? Like, I should just be able to do... okay, so for... it was output that needed to preserve accumulator, right? They both need to preserve one of the flags and... yes, output preserves the accumulator. So we don't care about the accumulator for purchur. But they both need to preserve Y. So, yeah. I think I'm just going to do it here, and this should be fine. So, transfer Y into A. Wait, hold up. God damn you. Okay. It doesn't say anything about preserving X or anything, so let's do this whole frickin' song and dance. We will transfer A into X temporarily, then transfer Y into A, then push A, then transfer X back into A. I know. And, okay, we also need to preserve... Yeah, let's transfer... What is the instruction for? Transfer the status register into the accumulator. That stack pointer... No. There is one, right? Am I thinking of the 65816? That would be annoying. Clear decimal, clear interrupt, clear overflow, compare, decrement, 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 exclusive or increment, 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 Jump, jump subroutine, load, accumulator, load X, load Y, logical shift right, no, or push A. Ah, push processor status. That's what I need to do. Cool, that's easy. I knew there was an instruction for this, but it's not for transferring into A, it's for pushing it onto the stack. Cool. So then after this, I should just be able to do, is there a, yes, pull processor status. Why is my indentation all wonky? I don't know. I'm just going to go with it. PLD, and then pull A, and then transfer A to Y, and that's all she wrote. Was this the one that needed to preserve the accumulator? I can't. Yes, it is. Yes. Put character is the output. So, I guess we can just push A here. I don't know if my code does preserve A or not, so whatever. This is overkill, but I'm just going to go with it. Then we'll just pull A. So on the stack, we will have the actual value of A. We will have the status register. We will have Y. And then we pull those off in order. A, status register, Y, and we place that back into Y. Oh, moron. Yeah, this is going to overwrite the value of A, isn't it? So let's pull A, do that same trick, because we don't care about preserving X. Transfer A into X, and then transfer X into A when we are done pulling everything off the stack. That's terrible, but you know what? Just, we're getting a monitor working here, okay? It's better than the code that didn't have a monitor. And then same thing here, but we don't have to preserve the status register. So transfer AX, TYA, push A, PHP to push the status, then transfer X back into A, then push A onto the stack to preserve, no, that's the thing we don't need to do for this one. Then pull the processor status word and pull A and transfer the value from the stack back into Y, and we're golden. It's going to add a bunch of instructions for every place this macro is called, but I think this sticks to the spirit of the whole thing. Oh boy. Chat, chat, chat. Yeah, you can push it on the stack. You might have to test the bit and push the result. Yeah, I was wondering the same. I mean, I don't know. It just says I need to preserve that particular bit, so I figure preserving all the bits is just as good. Yeah, Trey Dempsey said, never mind, and ordering is important. Yeah, it is. Key presses and character printing are still relatively infrequent compared to the length of time an instruction takes. Yes, that's true. This is why I don't care too much that there are so many obsequious instructions here. All right, you want to see if it builds? Oh, wait, we forgot a very important thing. We need to call, I'm going to rename this really quickly to, well, no, I'm just going to leave it just in case. I don't want to screw anything up. I don't want to screw anything up. We need to find entry. And oh, this is, wait, I do need to reorder things because we're going to get to the end of entry and it's just going to fall right into the CMON stuff, which is not what we want. We actually want to move all of the entry stuff like after this. I mean, I guess it's not like it really matters because I mean, either way, I'm just going to do a jump into that code and be done with it, so yeah, we reset the floppy and then we'll skip all this stuff by just doing enter the monitor. And it'll just be jump, init, done. Now it doesn't matter where this is, it's going to jump over all that crap. All that crap. And get to here. Though this is all like defines and stuff, so it probably would have just fallen straight through anyway, but look. It is what it is. Alright, want to see if it builds now? Range error. That's interesting. 351. I don't want to mess with somebody else's code. I mean, I guess this monitor code. Like, it's saying FA or FFFA, which is -6, so why didn't they just put that here? Maybe it's just for the code to be more readable? But I think it's okay to put a literal FA here. Maybe. And then same thing here. I'm not sure why they give you options, F1 or FFF1. Is it because, like, maybe if you're running on a 65-816, but you would need to switch it into non-emulation mode first? Eh. We'll find out. Symbol print string is undefined. Where are we actually calling that? There's my question. Oh! Yes, that would be where. That is some code that we can get rid of. Yeah, get rid of the... I'm so sorry, we're getting rid of the to the left printing. Ah well, ah well. So it goes. Goodbye. Goodbye, sweet prince. But those were the only things I errored about, so... Oh, more range errors! The frickin'... What? What on earth? 187. Oh, wait. No, yeah. 187. What? What? What are you talking about, Mr. Linker? Okay. No, yeah, 187. Huh? I'm going to line 187, and it's calling JSR init keyboard, which I am pretty sure is not 65631. Yeah, Trade Dempsey said, yeah, I think it's 8-bit versus 16-bit. One would think. But what? Okay, let's just check another one of these to see what on earth it is talking about. JSR out CR? I mean... Is it because the addresses were putting things in? Oh. Is our code bigger than our memory area at this point? That would make sense. That it's saying I can't jump to things when their address exceeds the addressable range. Fascinating. Really? You got that big that fast? I mean... Like, the lookup table and stuff should be way... Well, it's not included, so that shouldn't be taking up any of the space. But... Interesting. Hold up. So where... So code main... I mean, I guess I could believe it? That just seems like that monitor shouldn't even be nearly that big. We have an 8K chunk that we're playing with, I think. Let's look at that. The link configuration. Code main starts at E0000. So we have 2K to play with. So our code is bigger than 2K, which I am surprised by, but I find believable. Like, if I bet it's right on the edge. Like, if I switch this to, not that this would work for our purposes, but if I switch that to D1000, I bet this will build just fine. No, really. Oh. And it's saying it is overlapping the PRG area. What? It's too low in PRG by 4096 bytes. All I've said is that we have program memory that is this big, which is that 8K? Yes, maybe. It is too low in PRG by 4096 bytes. Oh, wait. Because I said blank area is of a certain size, didn't I? 1 second. Blank area. Yes, because I said that is E0000 in size. So let us, again, this is just to prove that this is actually the issue. I'm going to switch this to, I don't know. Let's go with C. Be real conservative with this, just to make it work. And also set this to start at C. That's what's up. Now it's too low in PRG by 8192 bytes. What? Actually, what? I do not. Oh, of course, this is the sizes. That's 65K. Or, you know, 61 over 64K. That's what that size is, obviously. So, what the shitty fucks. Everything is saved. I haven't screwed anything up in terms of saving. Blank area is C1000 big. That's it. And this starts at C1000. What do you want from me? What am I screwing up here? These are still giving me range errors. As if this didn't take at all. I'm gonna look at chat. I bet nothing is being said, but Trey said, what is init keyboard defined as? But I think we're past that now. Is it a symbol or some kind of macro? It's a symbol. Wereworm says, maybe an alignment issue. Trey says, yeah, I think you're right. What's your origin? Again, theoretically, that code main segment, which contains basically all of the code, you know, it starts code main. It starts all the way at the start here, includes entry, all of the entry code, which means that entry starts at whatever we define that location as, or that, you know, the size of the blank area and the start area and the start of the code segment there is exactly where that will wind up. And then we have blah 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 blah, all the CMON stuff, which, like I said, as far as I know, like, didn't look like it defines any segments in here. So that shouldn't be screwing up the segmenting stiff. More stuff, more stuff. There's the end of their code. There's a little more of our code. Init keyboard, get key, puncture. More puncture. And that is the end of that segment. So that, everything up to here should be that code segment. Then we have the key lookup table segment, which, where did I find that it's starting? I mean, it doesn't. All it says is that it's aligned at 80, so it follows whatever was before it, and it's aligned with that alignment. Same thing with the character lookup table, and then the vectors. And yeah, all this is saying is that code main starts at C1000, and that's all it says. Anyway, I didn't finish reading chat. Oh, because of your code entry vectors, says Wereworm. You have to find the code entry vectors at FFFE or something, and the monitor is below that. Yeah, that's the way it should be, because that these are hard coded to the end of memory, because that's where they go. They're the last 3 words in memory. But this is just the question, is what does it mean for the address to be too low? How can it be too low? Like, before it was saying it overlapped with other shit, but now it doesn't say it overlaps with other shit. It just says too low. In what way? All the program memory area definition says is that it starts at 0, it extends for 64K, it's read-only, the file is the output file, we fill it, and the value we fill it with is zeros, and then the segments that are in there is the blank area starts at 0, and then is however big blank area is, which is defined as, it's defined in here. That blank area repeats a 00 byte C1000 times. So blank area should start. Yeah, it says it starts at 0 and is C000 big. Then code main starts at C000. So they're not overlapping. They can't possibly be overlapping. Let's just start address is too low. We're just going to Google CA65 start address is too low, which will probably get us nowhere. Here's somebody with an issue. Help me, please. Too low. Sorry, please bear with me as I just sit here and read. Blah, blah, blah. They're talking about a bunch of stuff. I love reading these and just having people give advice that you know is wrong. Like these people that are giving them advice on the error messages that CA65 is giving them in terms of what kinds of Nintendo games exist when CA65 is not constrained in any way by the Nintendo. Okay, this person just wants to know about this compile issue. Reading. And didn't answer the question at all. Super cool. That's it. Why is it telling me header start address is too low? Why is it overflowing? And Nobody says anything. Cool. Let's try something really silly just to make sure it's not the blank area issue. And let's see. Yeah, blank area. Let's even just completely remove the repeat and have it just be 1 byte. And I'm sure it will still be an issue. Yep, start address is still too low in PRG. What? How? Why? How so? And yet, if I put it at E, will it still give me that warning? Interesting. It does not give me that warning at all. Why? What is the magic about E1000? What could possibly be? What? What? I'm going to get rid of these really quick, because these, it skeeves me out that it seems to know things about the memory map that are not written down. Do. Yeah, I think those were the only things. I'm sure that won't make a lick of difference, but let me. Because I can understand it saying these spots, they're too high in memory now at this point. I could believe that, especially because they're so close to falling off the end of memory, you know. Because 65536 is the end, and we're getting addresses like 657, 659. So I would believe that, but the fact that when I move this back to, again, I don't think I have any alignment on this, as far as I know. So, like if let's even just set this back to 8000. Which is what I would honestly like to do. I think that would be the solution that I would do at the end of the day, because there is another 8K chunk. Well, there's a few chunks of SRAM that we can use, but we can just enable the last 2 8K chunks of SRAM from 8000 through to the end. With the MMC, it's just that the 8000 area, like 8000 to DFFF, is you can't necessarily know at startup time if that's mapped properly, so you have to map it and then jump to the code that's in there, which is totally fine. But I'm probably going to do that if this is just too big. But just the fact alone that it's like kvetching about things being too high or too low when it should be arbitrary. Okay. So I think it's just bombing out because previously it was... yeah, because we have a ton of errors here and then... Oh! Oh! Now I feel really stupid. God damn it, guys. You know why it was giving me linker issues? Because it was during the link phase and it didn't delete and or update that O file. So that O file was old. That's why. Derp. So we still have these range error issues, which is honestly kind of strange because this is just in the source. So it's definitely not 60, like in the source has no idea where in memory it is. So like the addresses, you know, it's building a relocatable object file. The addresses that are inside of that segment are relative addresses inside of that segment. So they should not exceed this address. Also, how many different ones do we have? We have 596, 575, 575, 729, 729, 729, 729. Yeah, they are a bunch of different things. I was wondering if I was going to see the same addresses showing up over and over again, and we do see a few of them, but not a huge number of them. Yeah, this just stood out to me. Trey says, +1 for not using a make file. Yup. Trey says, take your time. I'm trying to. Lahuel Roman says, Guten Abend, NES hacker. Guten Abend. Trey said, is it just me or are forums almost never useful? No, it is not just you, Trey. It is not just you. Yeah, Taco Man says, they are sometimes useful, but not all the time. I find it to be, I'd call it 50-50. My gut says that's charitable, but I think that's realistic. Trey Dempsey says, are you sure basic.asm is placed at code main? I mean, that's, like I pointed out, that's supposedly all of that code up until the next segment thing, everything from here through is in the code main segment. So, and again, the source prior to linking doesn't know where it's going to get linked to. So that's the weird thing, is that it's complaining about addresses being off the rails. So the real question is, how could the relative addresses inside of this code, even if this code is bigger than 2K, how could the relative addresses inside of this code be so much bigger than 2K? What is screwing that up? Is it something inside of the monitor code that is doing something weird with the pointer in the assembler? Maybe? Oh, the fuck. It's right there, you guys. It's right there. Gross. Okay, so they are trying to place reset vectors, but we don't want to do that. So I was wrong. They are trying to place reset vectors, and oh my goodness, whoever wrote this code positioned it in memory by literally counting the bytes of each version of the built code and then setting the org based on the size of the... Wow. Amazing. Okay, so yeah, I did think... I saw some stuff at the end. That's why I was kind of confused. Yeah. Yeah. Because this is setting the address of the break handler if you enable the single step stuff at the exact address here, and then byte 5.6, which is, yeah, we're gonna get rid of, I mean, I guess we don't really have to get rid of all of this. It's just gonna be dead bytes. So whatever, I'll just leave that for now. But that's what's screwing it up, is that they are literally hard-coding placing this thing at the end of memory by doing the org at the beginning here. And when you enable single step, it makes the code slightly bigger. Wow. Okay. Well, let's just get the hell rid of these. Yeah, we can get rid of that entirely. There you go. There's your problem. There it is. Which also means... I was going to say, it would be crazy to me if this whole thing was bigger than 2K in the first place. So, that explains that. And now let's make... I now think this actually wasn't necessary. I have the blank area thing, but I don't think I need that at all. So I think that was there originally when I wrote this, because I was trying to, like, hard code the blank area without using segments in the linker and stuff. But this should just, because there's nothing defined between 0,000 and E,000, it should just fill it up automatically. I don't think I need to do that anymore. I mean, I don't think I needed to do it in the first place, but I think I can definitely get rid of it. So, let me do that while I'm at it. Okay, let's see. I feel good about this. Yay! Now, who knows if this code is going to work, but there we go. There it is. Reading comments, now that I have pulled that off, and then we'll burn it, and then we'll see if it, you know, works first try, which I don't want to say I feel confident about maybe it working first try, because if you get confident, that's when it bites your ass. But I feel okay about it. Yes, comments. Yeah, Francois said that's why people invented makefiles and dependency tracking. Yeah, I really should have made this just a makefile project instead of this stupid link script, but get out of here. We can clean that up anyway. And Francois said, actually, there's NMake on Windows, by the way. And yeah, lots of... sorry, I'm going to skip over most of the ones that are about trying to help me solve the issue, because I finally got it. Sorry. You guys were helpful at getting me there, kind of. Yep, part of VS Code. Yeah. Yeah, Francois says, unless you want to keep the size minimal, there are other ways to put the vectors at the end. Yeah, we're using an assembler with a linker and stuff here, so we can just tell it where to place. We have this little vectors segment that I set up right here, and I literally just say place this where. This isn't all of the vectors. I'm not defining all of them, but you know, place it 3 words before the end of memory, and that's all. Worm says, was close with the start vector thought. Yeah, I mean, like, that's the thing, is that's clearly what it was the whole time. I just couldn't figure out how it was possibly shoving the start all the way to the end there. And Taco Man says, never trust the first run. Yeah. Well, we're going to build it, okay? Make sure it actually got over here. Yes, it got over here. Cool. Let's do the thing where we do the thing. And then hopefully now won't have to do this thing. Oh no! You know who was I was saying maybe it was Trey that was saying just give yourself a monitor, damn it. I mean, a lot of people were. I think the person who kicked that off was Dave. So point to Dave. Next time we have a sesh here and Dave manages to make it, everybody say, Dave, he did it. Dave, he actually listened to you, Dave. He will be happy with that. Because Dave I actually know, well, I also know Trey in person now too, but Dave is my VCF buddy. Wow, okay, let's not get too distracted. We need to actually load the code, maybe let's do that. I'm gonna be so stoked if this works first try. Then I have to learn how to use it. That will be a thing. Okay, it's born. Place your bets now. Place your bets now. Trey says, yeah, that wasn't me. I said get Ziff Socket. And you got Ziff Socket, Trey. You got it, okay? Now let's let Dave have his thing. Come on. We got the Ziff Socket eventually. It was always you guys have the best tips because I am the dummy and you are the smart people telling me the right things to do. Yo! It's supposed to print a dash for its, yeah, let's learn how to use this thing. And Trey says, let's load up gorillas.base. Hell yeah. Okay. So I think what I want to do here is, let's learn how to use this monitor. It has documentation, which is fantastic. And we're gonna read it. All right, so let's just read an example. So you write an address, and then you write a command, and that's it. So I think that's pretty much it. Oh, yeah. Okay, so comma is store a 16-bit value. At is set the current address. G is jump to a routine. And X is dump, and that's it. So, yeah, let's try one of those. What should I dump? Let's dump... Oh, it always dumps 128 bytes? That's interesting. Also, why is it always 16? This person was definitely doing this on a 65816 or something, because it dumps 128 16-bit bytes. Why? Okay, whatever. So I guess what I'll do is dump from... Yeah, I'll dump from FF... I'm losing my mind. From FF00. That'll dump the last 256k 256 bytes of memory. Theoretically, according to the way that this is written. But let's see if these routines even work at all. So, what are we doing? F. Well, yeah, this doesn't work. It's not getting keyboard input at all. So that's cool. That's fun. Alright, well I think we can actually debug this one in the NES debugger. That's the good news. Let's go do that. Where it says, one day there will be a power indicator. Technically, well, we have this thing in reset, but technically that LED turns on when the thing turns on. Dave is here! Dave, we're putting a monitor in the damn thing, except that the more I look at it, the more insane this monitor looks at. What is the 65 org 16? I need to look this thing up, because that's what he made this monitor for. There were probably better monitors I could use. This was the first one I found. And I was like, this seems good. Seems minimal. Oh, god damn. God damn it. God damn it, Big Ed. The 65 org 16 that he wrote this thing for isn't a 6502 base single board computer. It's his own 6502 work-alike 16-bit. You absolute fucker. Okay. Well, what the shit? Okay, so I will say, I came to this page on the basis that somewhere someone said, oh, here's a good 6502 monitor that somebody wrote. The original page is gone, but it's backed up here. And Big Ed has apparently totally changed this thing for his processor core that has totally different addressing. So that's cool. Do I have to debug Big Ed's code? I don't really want to. That was not what I wanted to do here. I want to find the original frickin' version of CMON. But it looks like he made it for the 65 org 16 in the first place. How did I get here? Hold up. I just want to know how I got here. Okay. Bruce was the guy who made this in the first place. But Big Ed, I think, is the guy who made the 65 org 16. I'm sorry, I am falling down a rabbit hole. What the hell? For sheer minimalism, try his compact monitor. Here's Big Ed's copy, backported to the 6502. Okay. So he says it's backported to the 6502, Big Ed says. Alright, let's start by assuming when he says it's backported to the 6502, he is telling the truth. And let's just pop this into the emulator really quick and find the first place that it does a get key and try and understand. Well, we can't. Fuck. Because we don't have the keyboard in the emulator. So I can't. Alright, do I put in code to just always have get key return a value? Yes, I think that's what I do really quick. Just so that I can run it in the emulator, and presumably, if I just have it return a value every time and run it in the emulator, I would expect it to have the same behavior, and if it doesn't, then it means that something is weird about my code, and it's not just returning a value or something weird like that. Let's start at the place where yeah, you're not looking at my screen. Fun times. I was referring to this forum. Sorry. Alright. Shit can never just work here, so let me just look at my code really quick to see if, firstly, in those macros, if there is anything real obvious that I scunged up, like, for some reason it's always returning a 0. Could be a thing. What am I looking for? What am I trying to do? I am trying to, have get key. Okay, so firstly, is this macro stupid? So it takes A, puts it in X, takes Y, puts it in A, pushes the status register, puts X back into A. Oh, that's unnecessary. That's unnecessary, huh? I mean, it shouldn't really make a difference, but we don't need A to be passed to get key. Oh! Yep, there it is. I knew there would be something nice and stupid. So firstly, not necessary. We don't need to preserve A here when we're getting a key because we're not passing A to get key. You dingus. So it's fine to fuck up A. I think he said that A doesn't matter there. Let's see. For input, yeah, preserve Y and D. That's it. So we preserve Y and D. Then we do that. But the thing is, this is where we need to transfer A into X. And then, yeah, so we back up, because get key returns the value in A. So this is, like, this right here is going to overwrite the value of A. And before we return, we need to make sure we return get key in A. So now, let's take X and put it back in A. That should work better. I like when I just read the code and it seems obvious what the issue might be. Okay, let's try it again and hope that was the thing. Yeah, key was returned in A tray. Let me try and multitask. This is a thing that I'm not very good at, but, you know, if I practice, I can potentially get better. Maybe. Because programming this thing is the most boring, repetitive part that happens over and over and over again. So if I can try and program while reading chat. Anyway, if I'm going to do it, let's do it. I think guess a number is probably more this basic interpreter speed. Yeah. Seeing as we don't even have a basic interpreter yet. And then we got to Dave's, if you haven't broken it yet, are you even trying? Trey said, if it was supposed to simulate a cursor, then we won. You're damn straight, Trey. You know, if you, the way to success is just to move your own goalposts backwards until they pass you. It's not to go through the goalpost. It's to move the goalposts until they go past you. Because it's relative, so it's the same thing. We know this about physics. Before I turn this on, let's finish this off. But the print char works. Only the get char is broken. Hopefully we just fixed it, said Wereworm. Trade FC said we can't see your screen. I know. I'm sorry. Wereworm said, but that explains the invalid 42 opcode. Does it? Oh, right, because I see what you're saying. Because of it probably being a totally different instruction set. Yeah. And I answered Trey, how's the key returned top of the stack? Nope, it's returned in the accumulator. Yeah, and Trey, seriously, I will take a pause here because I always end up going on little rants, but I like them and they are important because also now I'm in a managerial position now, so like I spend all day, you know, teaching my juniors how to do shit, which they're generally good. I love my team, honestly, just to say, but this is a surprising. It's amazing how many people get to the point of being professional developers and just completely lack the skill of start by looking at the code and seeing what it does, you know? I would have thought that was like the first thing you learn, but yeah, if you have to jump into your debugger, it should be because you looked at it and you still didn't quite get working through the code because it's really hairy. Or because you need to see like in situ data. That's a good reason for having to bust out the debugger and just run local. But yeah, if you can't just step through your code, work on that skill, man. That's the most useful thing. And Kyle Steinkamp said, "Fixed shower goal achieved." Yes, makes me very happy. Everybody can actually be clean now. Okay, are we stoked? Sweet. All right, that was something. Is that a hardware issue, or is that it totally fudging up the NES as a whole? Well, it didn't fudge it up in the same way, so that's a thing. But maybe it just jumped off into space in a different way. It definitely got the key and printed it, so that's something good. Let's see if, because I'm not supposed to be putting letters in there, so let's start. What I was going to do, right, was, well, should support hex. Let's see. Yes, I think it's just touchy. FFOO. Love my font. Space X. Oh, you sweet thing. Oh, it's so slow because of my print routines, but look at that. Oh, look at it. It's monitoring. FF78. Oh. I bet this. So the reason I did FFOO was because it said to dump, it would dump 128 16-bit words, but I'm sure that was just for this guy's weird instruction set. So theoretically, let's see. If we do FF80, it should dump 128 bytes, I would think. FF80. Oh, right. FF80X. And what I'm looking for is, if this is working definitely right, we should see the reset vector at the very end of this. And we do! See that E0? Yes! Yes! Francois, good time to sleep, because this monitor is... There's a lot of things wrong with this right now, but there's a lot of things right. I wonder why it's printing clocks. I think that's what I used for the @ symbol. I have no idea. It would be much cleaner if it just wasn't printing those clocks. It would be pretty much perfect then, but okay. Anyway, we have a monitor. I didn't have to write it. It took me 1 hour and 12 minutes to go from nothing to having a monitor. I will take it. I usually don't make... I usually do the dumb thing of trying to write everything myself because it's fun, blah-de-blah. But right now we're trying to achieve some goals. That's the fun part. And the fun part is not writing the monitor here. It's having some kind of local debugging so we can get this stupid floppy controller working. Trey, I've met you in person now. So I can picture you saying, well, we could make our own char ROM. And it's funny. And stop. Okay. Dave K says, now poke your disk controller. That's what I was thinking. Let me start by just... Well, what is the poke command? That's the question. Watch this weird-ass monitor not have a poke command. Anyway, I know I do go off on tangents, but the point there was that I'm very excited because normally I would like write the whole monitor myself and it would take forever. And I just got a whole monitor working in an hour and 15 by stealing other people's work and messing with it a little bit, which is, I think, really the way you get shit done. So that's fun. Okay. It's comma and increment address because it's a somewhat sensible monitor. So let us, yeah, so we set the address. Oh, yeah, so we write the address, then we do comma. Wait, what? I'm not sure. It's not incredibly, oh, wait, no. Sorry, I know you're not looking at the screen, but it's not necessary to switch back. So I think it's address, then the @ symbol, then the byte, and a comma. You end it with a comma. I see. And then when it gets to the end of the line, it is done. Maybe, I don't know. Let's try. So let's look at my old code really quick. Actually, remember when I said I didn't need to go to the screen? Now here we are. Yes. So this is the format of writing some shit in the 16-bit format. So we're just gonna have to assume, and then maybe I'll try and do the version command thing manually. One of the fun things is playing with this is that, like, some of the commands I might be able to do manually because they don't output much and they put it into the FIFO, so I should be able to do it at my own pace. But like when I get to attempting to read and write a sector, I can't do polling by hand, but at least we can write machine code in manually, so that would be a thing. Right, anyway, so looking at the old code, we were writing 10 to the motor status register. So let's do that. Is my power supply on? Yes, it is. Floppy drive is in, or floppy is in the drive. So I've already forgotten what that format was. I said the address was 6802. So yeah, I think it is 6802. Oh shit. Oh god damn it, you guys. I can't type an @ I can't type an @ because I never enabled shift. Oh, okay. There's an easy fix for this. I could write the code for supporting shift, but that's going to take longer than the quick hack, which is, I bet we can literally just go in here and find that character and change it. Because I guarantee you it's just doing a comparison against the literal character. It was the @ symbol, correct? Yes. Not found. Super cool. Super, super cool. Maybe it does it by like literal hex value? Doodly doo. Doo doo doo. Yeah. Dealing with numbers. Here's this stuff. Did he change it from wait. It's gonna be slightly painful, sorry. Comma @ okay, what calls @? That's how we figure this out. We have @ and branch to @. Oh, so yes, compares. Yes, so it compares it against the literal value. Right, 40 is an @ symbol. I'm sure somebody can tell me this long before I look it up. I can't keep these things in my head. Yes, it is 40. Look at that, right there. So let's just change that to some fucking other thing. And let's do it in my source so that it actually takes. Can't find it. Oh, probably because this is regex. Yeah, I need to escape that $. Yes, there you are. And because I am cool, what letter should we use? What letter should we use? One second. Let me see what my plus key prints. It prints plus. Fine by me. So let's use plus. Because that one I don't need to press shift for. Okay, I think that's our fix. I think that's all we need to do. Fingers crossed. Trey said the real question is, does comma work? It should. It's a lowercase on these keys, so comma should be okay. Should be okay. Build twice for flavor. Loaded. Probably should put the chip in there, I guess. Right. Multitasking. Oh, no. Turn it off. Turn it off. Turn it off before you yank that chip, sir. Well, I am doing the programming thing. Yeah, everybody was... Okay, so Trey said, surely it has a set command. I wasn't saying that it might not have a set command. No, I think I did say that. I think I straight up said that. Never mind, I won't defend myself there. Anything could be. Oh, Francois says, now write a GDB stub before I wake up. Legitimately, because I was, when I originally made the Genesis RAM cart, I was looking, because since it's a RAM cart, you can do, I don't know if it's what this debugger does, which wouldn't work with ROM, but one hack for if you have an interrupt command in your instruction set, an interrupt instruction, you can basically, if your CPU doesn't support, single stepping explicitly, you can, assuming your code is in RAM, you can make single stepping happen by just whatever mechanism the user uses to set a breakpoint, literally just take what was there in memory, stash it in a temporary thing, and then put a interrupt instruction there, and then just have your interrupt handler fall back into the debugger and replace the value, which you can't do with ROM, obviously. But yeah, I got kind of off track there, but so I was going to use that to do single stepping with my debugger on there, because it's a RAM cart, so you could always do that with the RAM resident code. And then I was thinking about that, and I thought, well, if I'm going to do that, then I might as well look into like how GDB remote targets work, and it is actually shockingly, I'm not going to say easy, but there's not much that you need to implement. There's like somewhere between like 5 and 10 commands. 10 even seems high. There's just this little handful of like primitive commands that you need to support, and that's it. You're done. You have implemented a GDB target. And I thought about it. But that said, I'm not going to do it for the NES right now. Yeah, I moved that chip over. We are all set. And a person's name who I cannot read because I would love to learn Cyrillic at some point, but I have not, says, good day. Hello from Russia. Hello, sir. Or madame. Trey says, for an NES, I'd think replacing the CPU with an FPGA would be easier for single stepping. Yes, but it would also be the devil. So, think about that before you say something like that again. Okay, we were doing 6802 address. And then we want to write something to it. 10, right? 10, comma, enter? I don't know if that did anything. 6802 plus 0? Here, let's do a real basic test. And where is RAM in this thing? Well, I know I have 0 page, so let's set the address as, I don't know, just 00FE. Whoa, key repeat. 00FE. Yes. And I don't know, let's write AA there. And then let's, God, I don't think I can do anything except for dump 128K block. So that's not amazing. Let me double check. Sorry, can't see my screen. This time I'm aware of it. I am actually aware of it. Yeah, no. No, you can only dump 128 blocks at the same time. Oh, Wereworm says, I think it spells Alexander, and Alexander says, yes, you are right. Thank you, Wereworm. Teach me Cyrillic while you have the time. Okay, so yeah, we just gotta dump that whole frickin' block. So, what will we dump from 80? Yes, we will dump from 80. And that will be 0080X. And we expect to see at FE AA, which we super duper don't. I don't see it. Do you see it? Because I don't see it. Let's see. So that very bottom line is at F8, so that's FF at 8, F8, FF at F9, FF at FA, FF at FB. Yeah, I mean, obviously. Obviously, that's not it. So let's just try a silly experiment just to see if I understand this command correctly. I guess I can just write it at 80. That will make my life easier. So if I do 0080, what even was it? Plus, and then I don't think it's overlapping. I don't think it's overlapping text. I don't think so. Yeah, it's just a very ugly screen. Mostly because of those question marks are really screwing things up for some reason. I don't know why they're there. Anyway, so that would be, let's write AA, comma, AA, comma, enter, and see if that did any more betterer. Maybe it only likes when you write more than one. Right, so dump, again, that's what we're doing. 0080X. Nope. Didn't do jack shit. Thank you, terrible monitor. Just a sanity check. Let's do a dump from 0, and we should see. Yeah, we see our 0-page shit for stuff that we're actually using. So it's not that it's not reading memory correctly, it's that the write command doesn't friggin' do anything. That's interesting. I wonder if it's because it was ported to still read 16-bit values. There's an interesting thought. Okay, let's try this. Let's try 0080, set the address, and then write 00AA, comma. Cool. Now 0080X. Nope. And there's no way to interrupt this, so we just have to sit here and frickin' wait every time. Let's try the other way around just for shits and giggles. Or, you know what, let's try. I suppose I could also look at the source in a minute here. It's not like it's complicated, but I also need to get out of here in a minute, so maybe we will cut this short at, well, we basically got the monitor working, and that's fun. Yes, so what was I doing? Clearly my brain is also starting to get a bit mushy with this. What was I doing? I literally just described what I was doing. Oh, right. 0080. Set the address. Subsequently, let's do AA55, comma, just for fun, AA55, comma, and now let's dump. 0080. Dump. No, still didn't do shit. Neat. Oh, Wereworm, you are right. That was not a comma. That's why. Wow. See, this is why I said earlier. You don't, well, maybe you do believe me. Maybe this is like watching a sideshow for entertainment, for morbid entertainment. You guys, better brains than me. I'm just plonking along. That seems very obvious, doesn't it? That ain't a comma. That's the piece of the star we used for greater than and less than. There you go. Well, okay, let's just replace... Let's do this again. Let's just replace comma with... Well, no, you know what? I'll do this semi-correctly because if I do implement shift at some point, we'll basically just have two lookup matrices, or lookup tables for the keys, and if the one that we currently have is the... Actually, the one that we currently have is kind of weird because it's actually the all uppercase keys, but I think there was no... Was there lowercase in the character ROM? I'm not sure if there was, so I'm not sure if it would really make a difference implementation-wise, but we have the numbers in there, so I'm going to call it the lowercase lookup table. So really, what I'm going to do is, if I want to use that lookup table later to actually implement shift, the lowercase of those keys are supposed to be comma in period. So let's revise. My code is in the code editor. There we go. And where do we keep that? It's at the very end. Key lookup table. Scroll, scroll, scroll. Yes. So greater than should be period, and less than should be comma. I think that's the right way to go about this, as if there is any right way to deal with my code. Damn, damn, damn. Trey Dempsey says, no, this is great. You're doing fantastic. I'm just part of the peanut gallery. No, don't worry. This is, when I say this, I am not feeling bad about myself. It's just, my skill is I have loosey-goosey ADHD brains, so I'm not very good at holding on to complicated ideas for very long. And I'm kind of, that's one of my Achilles heels when it comes to like debugging. Is if I have to keep a few separate, mildly unrelated things in my head state-wise at the same time, it can get hairy, especially when I'm tired. I just can't hold on to those things. But I'm really good at bashing at things until they work. And I think that's where it's gotten me in life. So I don't feel bad saying that. I have weird, incorrect brains for engineering. And so I have engineering brain people here that are better at that. Taco Man said, technically I just made an NES into a PC, so you're halfway there. What did you do? I want to know. Tell me your secrets. Did I build this? I never know. I never know. I'm sure I didn't. But there is no build so buildy that you can't build it twice. Pop out the thing, put in the thing. Trey said use a ZIF socket, and I said hell yeah. This is the part where I said I would read comments. Trey says, I have an artist brain that pretends to be an engineer at work. I think we have similar brains then. Because most of the other things I do or have done are artsy. Like, to me, this is more an art project than anything else. I think that's, there's a certain, and I would feel cool knowing that, like, that's maybe what might attract some people to this channel is I've always felt like I have a weird crossover. Not that I'm like a great artist or anything, but you know, kind of an artsy creative brain who is also interested in technical things, and so I tend to not be like so serious about, you know. Oh look, I took this out with the power being on again. Whoops. So serious about like let's build a product, and you know, for like day-to-day work I actually have to like turn that bit on, and it's not really natural to me. What I like is let's have fun and poke at shit, and do it because it's fun and silly, not to accomplish anything, because I have a brain naturally that isn't really interested in accomplishing anything. So yes, I think I can identify with that very much. Taco Man said, "I'm a little messed up from the meds, so I meant you." That is totally fine. You take care of that ticker. You just relax. Okay. Let's see about this comma situation, eh? All right. Yes. Let's just start with the simple. Write something to 80. AA is always a good test. And the way this monitor works, per what I was reading, is it just kind of evaluates keys as you enter them, and pressing return really just is for formatting if you want it, because all it does is prints a new line and a dash, but it doesn't really do anything. So like as soon as you hit comma, it executes the command. So I should just be able to do 0080 X. Yeah, look at that. And it actually fucking worked. It only takes me forever to figure things out. Wow, we're only at a little over an hour and a half. I am honestly surprised by that. Felt like when I said that we were at like an hour 12, that was ages ago. So that's nice, because I want to be done soon. I have other shit to do. I'll be up late tonight. But yeah, let's see about turning this drive motor on, huh? And then next time we can start playing with trying to do drive commands by manually doing them in this monitor. And maybe we'll make a version of the monitor dump command that doesn't always dump 128 bytes, because that's... Oy. Yes, so we have done this command a few times now. 6, oh, nope, fuck. Fuck. Oh, God. I chose the worst. Well, here's the fun thing. Every access to that area toggles this register, so. Floppy drive should be reset. I think the floppy drive is reset. What, do you think the floppy drive might be reset? All right, let's try this again. So that is 6802 is the location of that register. Set the address, and then write 10. Wow. So we're exactly the same place we were 2 days ago, but now we're doing it with a monitor. So I'm fine with that. Okay. You know what? Since it's easy-ish, I think I want to try. Well, firstly, 6802. Set the address. 00, comma, and you're off now. Let's see about that version command, huh? Let's look at that really quick, because that should be. Oh, let's do this. So here's a fun one. It would be nice if I could pull up the documentation on the screen too, but that is just going to get so freaking cluttered. So you're just gonna have to listen to me describe the documentation here as I am talking. So I need to. Well, the master status register is, I think, register 4, right? So if we dump 6804, this monitor is not going to work for our purposes. Okay, here's a quick, I'm sure we can, let's just make X dump a byte. Surely that is an easy change to make, because that's all I need. And the issue is, if we have it print a block of 128 things, it's going to start reading from other registers and possibly doing weird things. So let's make that change really quick. Udoodly doodly doodly doo. So that command is X. Where is X? Where do you do it? Where do you make that happen? Out hex. I don't even, this source. Okay, the main thing is I need to see where it's looping, and okay, I need to see where it's looping what it's using for its loop counter, how I can change that to just be 1, and then subsequently it also updates the address, and it would be nice if it just incremented the address by 1 as well. So yes, let's see. So out hex is presumably the entry point for dumping the hex stuff. Let's see. Oh, wait, no. Dump. I guess it's dump. Huh. I just love this code is how it's not, you know, clearly labeled in any sort of way. I mean, it's got to be dump. It's got to be dump. But I just want to be sure. Okay. Init jumps into the monitor. Doodly. Does a carriage return. Prints the dash prompt. And then loads a literal 0. Oh, stores it in the number register. Oh, 0 page address. I don't know. Does some shit. Then it gets the next character. If it is an enter, yeah, if it's an enter, then it prints another dash, does the whole thing over again. Otherwise, what is M1? Oh, no, sorry, M1 is the top. If it's not a printable character, then it tries to get another character, yes. If it is greater than, yeah, if it's over 7F, also not printable characters, then try and get another character. And then print the character we typed. If it was 2C, jump to comma. If it was plus, jump to at. Single stepping we don't care about because it's not doing that. Then now dealing with letters. Okay, yes. Because I guess we are. I just don't get this FA thing. So obviously it's checking to see if it was a G for go here, and if so, goes to go. And what is the deal with FA? What is M3? Oh, okay, so that just, M3 is the add another digit. Oh. I don't know, I guess something about FA. It says this was a digit or something, I don't know. Probably pretty obvious, but I'm mushy. Then, okay, what is M6? We were just there. What was it? M6 is getting another character. Okay, so if it was, I don't know, not a supported character, then try getting another character, I guess. Does it just dump if it wasn't anything else? Is that literally what it does? Oh boy. I think that is the case. Okay, anyway. The important thing is, where's the part where it looks for... Is it this compare 7F? What is D4? Put C. I guess where does this exit and jump to not going to be M1 that it jumps to. It's going to be something else. So this is the part where it's printing a character. I mean, that's, yeah, out hex is the part where it actually prints a character and figures out if it needs to do a new line or whatever. Oh, this is comma, which is, we have gone too far. Oh, there we go. Compare Y, width by height. Is that what they do? Wait, what? Oh, what? What? Okay, so when it, so, okay. God, this is dumb. So I think we just set width and height to 1. That's what they do. Width and height control the size of the block that gets printed. If this is what that is, I'm gonna be so angry. No, I'm not gonna be so angry. I'm just gonna sigh real hard. Must be a power of 2. 1 is a power of 2. Is this the hack? Is that the hack? We're about to find out. All right, I'm gonna turn off the NES. Yep, Trey got there same time. Height equals 1. Turn off the NES before removing the chip. Yeah, I'm trying to do the multitask thing, but the only thing I haven't read so far besides Trey also saying setting height to 1 is saying, that's weird. And you're right, Trey. It is weird. Load up the thingy with the thing. No, wrong. Load up the thingy with the stuff. Doodly doodly doo. Yes, yes, yes. Program it up. Ba ba ba. Oh, now I've run long trying to hit my goals. Is it worth it? Let me work it. Put that thing down. Flip it and reverse it. Power on. Okay, let's just do 0, 0, 0, 0, and X. Yes? Is that good? What if we do X again? What if we do X again? What if we write some known values? So let's do 0, 0, 0, 0, set the address, write 1122334455. I think that's a hardware issue. I've seen this happen before. Don't worry about it. And set the address back to 0000, and let's print stuff. That is... Oh, that's the extra stuff it's printing. It's printing the character values of the fields. Duh, that's why the extra stuff. Okay, so that's not a... Oh, it's also not... Yeah, something is real screwy because it's also not showing an incremented address. Well, I need to get the hell out of here. So we will resume next time, and we'll try and do some drive commands. But I'll need to figure out what's up with this situation. Because I want to just be able to dump 1 byte at a time, but clearly, it doesn't want to let me do that. Possibly because 1 is a corner case where the increment logic in there doesn't work correctly. Though it looks like it's dumping random garbage memory addresses, so... Meh. But yes, peace out. I have other things to go attend to now. But it is always fun spending time with you guys. And we have a monitor now, even though it's kind of broke, so that's a whole thing. That's progress. All right, as usual, see ya. I love ya. Bye-bye.